In this first example, we're going to look at a proof type question, and it says that show that sin x plus y is equal to the sin x cos y plus cos x sin y for x is equal to 13 and y is equal to 60 degrees. I'll just move that degree sign in. So the way to solve this is to look at the left hand side, that's what this stands for, and then look at the right hand side and show that they independently come to the same value. So let's start with the left hand side. So in this case the left hand side is equal to sine of x plus y, so in this case it will be sine 30 plus 60, and that comes to the sine of 90. So the sine of 90 is equal to 1 from the graph. If you think of the sine wave going up like that and down at 90, it's 1. So if we can prove the right hand side is also equal to 1, then we can say that the left hand side is equal to the right hand side, and thus we've proven this up here. So if we substitute the x and the y values into this, then we end up with sine 30 cos 60 cos 30 sine 60. And again, we need to rely on our exact values, either from memorising the table or using your wee triangles. So sine 30 is a half, cos of 60 is also a half, so that's a half times a half. The cos of 30 is root 3 over 2, and the sine of 60 is root 3 over 2. So if we multiply a half by a half, we get a quarter. And if we multiply this, root 3 times root 3 is 3, because it's root 9 really, which is 3. And 2 times 2 is 4, so it's 3 quarters. If we add these together, you get a half. Sorry, a 1. So basically we've proven left hand side equals right hand side, because we both get 1s, and therefore sin x plus y equals sin x cos y plus cos x sin y, for x is 1360. Okay, in this next example, we're going to look at some triangle work. So the diagram shows two right angle triangles. Firstly, we're going to split this question into two parts, work out the value of sin x and cos y. Now to do this relies on a bit of earlier knowledge, particularly Pythagoras and a bit of trigonometry. So if you're doing Pythagoras on these to work out the hypotenuse, because that's where we're going to start, you can either use Pythagorean triples or you can actually work it out, but this comes to 5. 3, 4, 5 triangle. 4 squared plus 3 squared comes to 25 square root to get 5. On this side this comes to 13. Again, you could work it out. 12 squared is 144, 5 squared is 25. You add them together and square root 169 to get 13. What we have here is we have opposite, hypotenuse and adjacent in both the triangles. Now, to get the value of sin x, you do opposite over hypotenuse from your SOHCAHTOA. And the same idea with cos y, you do adjacent over hypotenuse. So there's your Pythagoras quickly, your 13 and your 5. But your sin x is 4 over 5. And you can actually just work out your sin y and your cos y and your sin x and your your cos x. You might as well do it all, because in these expansions usually you need to deal with the cos and the sine of both angles. So we've got sin x equals 4/5, therefore cos x is going to be 3/5 adjacent over hypotenuse. And the same idea, we've got sin y here, we can work out cos y by taking adjacent over hypotenuse, so that's going to be 12 over 13. And this will really help us in the second part. Although we were only asked for sin x and cos y, getting all these values is a good thing. So in the second part of this type of question, we have to expand cos x minus y. And quite often when you do this kind of triangle work, you'll have to expand using addition formula. So we've got to show that cos x minus y is equal to 56 over 65. So if you expand this, you get cos, sin, sin with a plus in the middle. So there we have it from the formula sheet. Again, I just know this and you can learn it as well, but you can look at the formula sheet if you can't remember it. So you'll see we need cos x times cos y. So we've already done the work for that up here using our triangles. So cos x is 3/5 and cos y is 12 over 13. So we can write that in. 3/5 times 12 over 13. And then we can do sin x times sin y. So that's going to be 4/5 times 5 over 13. We have to prove that this comes to 56 over 65. So 3 times 12 is 36. 5 13s are 65. We can see we're going along the right lines because we've got the 65 in the bottom. On this side we've got 4 5s are 20 over 65, which comes to 56 over 65, which was what we're looking for.